Hi, my name is Gianluca,
I'm Aisha.
I'm Lincoln.
I'm William.
and today we'll be discussing our space elevator. So,
So,
first,
yeah. Sorry. Yeah, the first thing we should discuss is what are some of the limitations for the experiment that we designed?
so some of the limitations from our experiment would be that we can't necessarily use the data accurately because obviously there's different there's different variables because our space elevator would be part in Earth, part in space, and our experiment is just on Earth. We're not going to be able to account for the difference, for what
Gravitational
gravitational pull and whatnot, exactly. And also because our experiments would be on such a smaller scale, we wouldn't necessarily be able to compare accurately to what the actual space elevator to scale would be like.
Yeah.
So, do you think it would be a good test for what we're trying to do, but it won't be super accurate? Do you think it would be a good test?
I mean, personally, if you ask me, I think it would be a pretty, I think it'd be a pretty good test just because we're testing at the lowest point on Earth, and that's when gravity's gonna be the most. That's when it's gonna be the strongest pull. That's when everything's gonna weigh the most. Because as you get farther and farther out of the atmosphere, stuff will start to weigh less and less. Especially when you're completely out of the atmosphere and there's no more gravitational pull.
So, since we're just designing this experiment, or if we actually do this test, what problems would you run into if you're actually going to do it?
Problems?
Yeah. Problems.
I think one of the major problems that we would definitely run into would be cost. Just to build an actual space elevator to begin with is incredibly expensive. Resource gathering as well. We don't currently have enough resources on Earth to make a space elevator if we wanted to. So even to make the test one, it's going to be incredibly tall, and we won't have the same leverage. The space elevator works because a cable has a counterweight outside of Earth that's orbiting, so it's able to stay upright, it won't fall or collapse. While the test, I think one of the biggest things is it's not going to have that counterweight outside of Earth's atmosphere that keeps it upright. So it's going to be really hard to keep upright, and it's going to require a lot more construction and support and whatnot.
Yeah, and feeding off of that point, I think that a major problem would be just finding the manpower to actually do it, because this is such a big thing. This would be 80,000 miles of tether of space elevator. It would require probably cooperation from the entire world, not from everyone in the world, but a lot of different countries, all the major powers in the world, to actually help construct this and complete this and turn this into a reality.
Yeah.
I think it's not necessarily the cost, but I think it's the manufacturing power. Because the main thing, the issue of building it would be the space, the tether used, and the funding could come from one source, one government if it was particularly large, like the U.S.,
China,
Russia, But I think the resources required to and the technology needed will be the main issue. So I think you already answered this in my last question, but would expense be an issue? Would expense be an issue?
I touched on it a little bit. I don't know if anyone else did. Go ahead.
Okay, sorry. I feel expense would be a big issue, not only because we would need the money for the thing, but we would also have to have public support for that, because if we don't have public support, then we wouldn't really be able to build it, because if people are against our idea in the first place, how are we going to get the fundings for that?
True. I think because we haven't really had, and this is kind of a science fiction thing that's coming into reality. People kind of what is it?
Would rather focus on issues down here than up there.
Yeah, but this is also super important.
And this is going to be an expensive project, and for something that isn't going to have immediate gratification, it's going to allow us to get out of Earth easier, but it's not going to allow us to travel to another planet right away. Compared to spending that money and those resources on other things on Earth that could help other people's lives, I think that a lot of people are going to be against it. Even though long term, this is for the better. Short term, it might not be.
Yeah, and also because a lot of the material that the space elevator would be made out of is not fully developed. It's not fully there. The materials would actually cost way more.
Yeah.
So if so we're talking about so let's go back to a previous point of the experiment. So if something were to like fail, or if we didn't get the right results for the test, what would you guys like? What would we do to go forward? You know, in the new like either new testing or like a redesign. What would you guys do?
Personally, I said something about this earlier about support and structure of the thing, and I think that if we can't like support it, we can't structure it properly, we can't get it up right, we might have to rethink a test. We might either, I would think, to do one or two different tests, either scale it down even more and just make it a smaller until we could build a tether that can actually sustain itself upright, or the alternative of making something that's more like on the ground or leveled, and it just kind of simulates the pressures that a climber might feel when it's climbing up, but not actually make it climb up. I think that would be a lot more expensive, if I'm being honest, especially because that's a lot more complicated technology. But that might be an approach that we could go about. So yeah. Any other comments?
No. All right. So so after you finish with the experiment, what kind of experiments would you guys like to see in the future? Like of the future study or experimentation of the space elevator design that we came up with?
I feel like they should test the material that we're using, which for the tether, because like it would be able to withstand forces on of the Earth and environmental factors like space debris. So it would be able to protect us from things that like are in space, also down here, because it would be a really strong material.
So mainly like testing the tether out, not just like the climbers.
Yeah, and also probably like study more into like carbon nanotubes and try to make it as efficient as we can and as like strong and as we could, because like right now
There's a really small.
it's possibly strong enough to actually like withstand the forces that it would be withstanding, right? But we could make that better, and it could just be better.
Yeah. If I could piggyback on what John Luca was saying, one thing I would add to for a second test, if we actually were to build a space elevator and had it like up and running, the first thing I would try to test is nanocarbon tubing, and not only just how strong they could be, like test them to their limits, like just a small piece of them.
Right, not just a theoretical.
Yeah, see like how much they can withstand until they actually start to like decay or break, and then figure out how to repair them efficiently. Because keep in mind, this tether is going to be very long in space. If it starts to break, especially like in the atmosphere or like right outside the atmosphere, we want to know how to repair it.
Right, or something happens to the anchor point.
Yeah.
Like just something. They could be very rare, but if like, you know, over time, if we can't repair it or something goes wrong and we don't notice it, it could have very big consequences for the Earth.
Yeah, and not just that, it would just be like a waste of resources that we could allocate to somewhere different.
It would be very costly. So I think that's my final question. So this concludes the discussion.
Cool. It was a good discussion.
Thank you.
Thank you.